Geometry. What? We don't teach geometry at AUM. You are correct. So this is the only class in geometry that is offered at AUM. Congratulations. But in theater and stagecraft, you have to know what some things are. And most of those things have to do with geometric shapes. Because again, we're making these things that are on stage that are creating this illusion. And sometimes the illusion is rectangular, sometimes it's spherical, sometimes it's triangular. All those things can have subtextual meanings, for instance. Ooh, just talking about lines. Again, this is totally sexist, but it's the way that the world works. Straight, hard lines tend to be masculine. Curvy lines tend to be sensually female, yes? And so we will have designs that have those elements there. And so as a builder of these things, you need to understand why how those things happen, yes? And again, it's one of those things where in life, those things are expensive. Anytime you have something that's not a straight angle, it's expensive. If you have an expensive house, you probably have some angles that aren't 90 degrees. Probably the more expensive the house, the more of those you have. If you have a less expensive house, trust me, every angle in the house is 90 degrees because 90 degrees is the cheapest angle you can get. But still, that's geometry, and it's you need to know what's going on. So first of all, let's just talk about, here's something you probably never thought of. What's an inch? Somebody says it's 12 inches long. Okay, well, a foot is 12 inches long. Great, so what's an inch? Well, it's 1/12 of a foot. That's what an inch is. Brilliant. If you look it up in the dictionary, I promise you, it's gonna say something about wheat. What? Wheat. It's gonna say that an inch is 3 pieces of wheat laid side by side. Great. That is great. Except that I've been around wheat and no pieces of wheat are exactly the same. So what's an inch? Some people will tell you this bone in your body, your thumb bone here, right here, is the closest bone in your body to an inch. So some people might say, oh, that's an inch, except that I promise you, my bone on my finger and Cody's bone on his finger are not the same. So come here, here's much larger. Perspective, exactly. But just so you know, an inch is just a measurement. That's the easiest thing to remember about it. So all these tricks are not going to rely on measurements. You're welcome. I would suggest to you that every time you measure something, it adds to the chance you have done it wrong. So what the other option is you take it and you put it in the space and you mark it in the space where it's going to take. And that way when somebody says, how wide is this? And you say it's 18 inches wide. If you put the board there and mark it, it is now 17 and 7/16 wide, which is not 18 inches. Yes? I know I'm going to cut the board correctly because I took it to the actual door or whatever it is you're filling with the board, and I actually marked a physical mark in the space. So I can be 100% more certain that my board is going to fit now because I marked it on the object. Does that make sense? I didn't have to have a tape measure. Yes? Now, if you don't have the object or if you're creating the object out of nothing, you got to start somewhere. So the tape measure and inches are a good place to start as any. Again, if you're in England or other places, you can use the metric system. We're not going to get into that. First of all, let's talk about what a line is. A line, we talked about the second day class, what lines can be. But a straight line, is the shortest distance between 2 points. When you have 2 lines cross, yes, you are going to create 4 angles. Wherever, no matter how they cross, if you have 2 lines that cross, they have created 4 angles. Yes? Now, we talk about angles in terms of degrees, just like inches. I have no idea why. But I do know that the way historically, and it goes back to prehistoric times, the idea of having 360 degrees in a full circle has always been there. And so if you take a line the definition of a line in terms of angle degrees, a straight line has 180 degrees in it. If you take two lines and cross them, you now have created 360 degrees of angles. Trust me. Before I get into this, it may be more helpful if you watch this little video about some angles, then I'll come back and reiterate some points.
Welcome to MooMooMath and Science and Vertical Angles Explained. When two lines cross, they create angles and share a common vertex. Vertical angles are the angles opposite each other when these two lines cross that share the same vertex. Vertical angles are always congruent, which means they're equal. In this example, A and B are vertical angles. Now the vertical refers to the vertex where they cross, which is labeled C, not up and down. Also notice that two pairs of vertical angles are created when these lines cross. Now notice what happens as I move one of the lines. New vertical angles are created, and they're always equal. And here's another example. Now, a classic example you may see with vertical angles is this example. Find the missing angles. Because angle B is vertically opposite 30 degrees, it must be 30 degrees. Now, a full circle is equal to 360 degrees, so that leaves 360 minus 2 times 30, which is 300. So angles A and C are also vertical angles. So 300 divided by 2 is 150. So here are all four angles.
So that's easy definitions of angles. Where the two lines cross, that's the vertex. And then the two angles across the vertex from each other are the vertical angles. Every vertical angle, if the lines are straight, which again, if you're in curvy line territory, they're not necessarily straight. But if you have two straight lines that crosses the vertex, the two vertical angles will always be equal. Yes? And the straight line, he did that complicated math thing about dividing by 360 by 2 and all that sort of stuff. Once you find out that one angle is 30, the whole line is 180, so you could have easily just taken 30 degrees away from 180 and the other angle is 150. That's another easy way to figure out the size of that angle, yes? All right, some terms for some angles. A right angle is any angle that measures 90 degrees. So it's called perpendicular to the surface. Any line that is perpendicular to the surface, by definition, is a 90-degree angle. Lines that are parallel are two lines that are equidistant at every point, so they will never cross. So those are two different types of lines: parallel, equidistant, perpendicular, 90 degrees to one another. Yes? All right, I don't want to go too fast. Slow the video down if you need to. When you have the two lines cross, you will create four angles. If it's at 90 degrees, you will have created four 90-degree angles, four right angles. If the lines are anything but 90 degrees, you will have created two acute angles and two obtuse angles. Yes? The acute angles are any angle less than 90 degrees. And so you've got this angle over here is less than 90 degrees, but you have this angle over here that is more than 90 degrees. That's called an obtuse angle. Yes, and when you add the acute and the obtuse angle together on a straight line, that creates 180 degrees. Cool. Complementary angles are the angles on either side of the vertex. Complementary angles are the ones that add together to create a 90-degree right angle. Supplementary angles are two angles that combine together create 180. So complementary 90, supplementary 180. Sorry, I didn't mean to confuse you there. Cool. Now let's talk about that's lines and angles. We'll talk more about triangles here in a second. Circles. A circle is a figure that the line created in a circle is the same radius, the dot of lines is the same radius equidistant from a central axis, from a central origin point. Yes? So again, you could take a string, you could take a board, you could take a stick, and draw a line around a central point, and that creates a circle, okay? The origin is the center of the circle. The radius is the length from the origin to the edge of the circle. A chord is any straight line that runs through the circle. If the chord hits the center line, it is also a diameter. So a diameter is a chord that goes through the center line or the origin, however you want to put that. A chord is any line that runs through the circle in any other means. And a radius just radiates from the center line of the origin to the edge of the circle. Yes? Any part of the circle on its surface, but not the whole circle, is called an arc. We create lots of arcs in theater. Yes? The circumference of a circle is the distance all the way around the circle. Yes? The way you achieve the number on a circle, that's how you derive pi. The circumference of a circle is defined as pi times the diameter, or pi times the radius plus the radius, 2r. Either way, 2 radiuses is the diameter. So pi d is the way you find their circumference, and it is how pi was discovered. Because pi is an infinite number that doesn't end. Let me see if I can get you the pi. And if you don't understand this, hit pause, skip for about 2 seconds and then come back. Here's how you get to pi, yes? If you take any distance from one point to the other and divide it in half, yes? You can keep dividing it in half and keep dividing it in half to keep dividing it in half, theoretically. And the thing about pi, because it is an abstract number, it's not a real number, it hasn't found an end to it yet. That's because you keep dividing the circle into smaller and smaller bits, and they haven't found the size of a single point yet, if that makes any sense. So that's why pi is a growing number. It doesn't end, because you can't find the absolute end of the inner circle. But in the larger sense, it's about 3.14. And again, that's just happenstance. Whatever the diameter is, you multiply by 3.14, you have the length of the circumference. Yes? A secant is a line that passes through a circle. A tangent is a line that passes through the circle at only one point on the edge. A tangent. So that we use tangents a lot in theater. A sector is any 2 radiuses that create any 2 radiuses. A quadrant is 2 sectors that are 90 degrees from each other. So any 2 radiuses create a sector. Any 2 radiuses that are 90 degrees to one another create what's called a quadrant. A segment is any chord, the smaller part of the circle is what's called a segment of the circle. Again, those are just definitions. If we need to go back over them, we can. I didn't make up any of the terms. That's just what they're called. Yes, and they can be very important, because let's say you're building the circle. Let's say we're building something in the round, right? We have something that's going to roll around. We've got a 4x8 platform to form the beginning, and so the line that is the segment here that Cody's going to show you. Let's say that's the 8-foot side of the platform. Well, then you need to figure out what the arc of the circle is to create the segment, to finish the circle. Yes, that's why we might need to know that sort of stuff. Cool? And again, the area of a triangle is pi r squared. Take the radius and square it and multiply it by pi, and that's the area of the circle as opposed to the circumference. The area is all the stuff inside, the circumference is the distance around. Yes? All right, let's talk about triangles. Triangles are defined as 3 lines that intersect at 3 points, right? So you have 2 lines create 2 angles. When you add the 3rd line, you create a triangle. The lines are called the legs of a triangle. The angles of the triangle are called the angles of the triangle. Again, by rule, first of all, you cannot have more than 1 obtuse angle in a triangle. Okay, you can have 3 acute angles. in a triangle. For instance, an equilateral triangle has three 60-degree angles. Those are all acute angles. Yes, but you cannot have more than one obtuse angle because, by definition, when you add all the internal angles of a triangle together, you come up with 180 degrees. So the angles in a triangle are all complementary to one another, if that makes sense. Yes, there are two ways of talking about triangles. One is by their sides. If all three sides are equal, it's called an equilateral triangle. And by definition, all the angles are 60 degrees. If you have two of the sides that are equal, it's an isosceles triangle. If none of the sides are equal, it's called a scalene triangle. If you have the other one's the way to talk about it, again, we just talked about the obtuse triangle is where you have one angle that's obtuse. The right triangle, the right triangle is where you have one of the angles being a right angle. Again, with the triangle, we cannot have more than one angle that is right. Yes, just like marriage. Only one of them could be right. There was a famous Greek scholar named Pythagoras who came up with a theorem called the Pythagorean theorem that says the way you know if it's a right triangle, if you take the sides, A side and the B side, and you square them, it equals the hypotenuse, which is the side across from the right angle. And so A squared plus B squared equals C squared is the Pythagorean theorem. Now, let's see if I can break this down to you for a fun little fact. If you take 3 and square it, that's 9. If you take 4 and square it, that's 16. If you take 5 and square it, that's 25. So 9 plus 16 is equal to 25. So a 3, 4, 5 triangle of any size, in other words, it could be 3 feet by 4 feet by equal to 5 feet, that's a right triangle. It could be inches, 3 inches, 4 inches, 5 inches. It could be millimeters, 3 millimeters, et cetera, et cetera. Yes, it doesn't matter what you're using as your distance. If you have 3 of the distance on one side, 4 of the distance on the next side, and 5 of the distance on the hypotenuse, you have created a right angle, which is one of the ways you can find a right angle, 90-degree angle, which can become very important. Triangles are the strongest form in nature because in order to change one side, you change all sides or all angles. Yes? In other words, if you just add an inch to one side, you now have changed this angle and changed that distance. Yes? And so the angles and each one of those things work together to keep a triangle the same. Triangles that have the same angles but different size legs are called similar triangles. Yes? All right, let's talk about geometric shapes. Here's a nice little colorful drawing. Square, yes. Square is equal to 4. You have 4 sides to a square. All of them are equal in size. You have a circle. Again, you have an origin with all the points on a circle are equidistant from the circle. A triangle, 3 sides, all the same size, that's the equilateral triangle. A square, again, is a 4-sided object. A rectangle is also a 4-sided object, but in a rectangle, only 2 of the sides, all sides are parallel to each other, but only 2 of the sides are the same distance. And both of the 2 sides are the same. A rhombus is a 4-sided object where the 4 sides are the equal length, but the angles are not 90 degrees. That's a rhombus. A trapezoid is a 4-sided object that has 2 sides parallel, but 2 sides are not parallel. Yes. A parallelogram is a 4-sided object. Yes. A quadrigon, if you must. That has all of them are, just like a rectangle, but not 90-degree angles. Yes. A pentagon has 5 sides, and 5 angles are all equal. A hexagon has 6 sides and 6 angles. An octagon has 8 sides and 8 angles. So again, those are some very, just names of different shapes that we may come across. Now, in theater, we also have dimensional objects. In other words, not just flat objects, circles, squares, and that sort of stuff. We also have things that are 3-dimensional. So a cuboid think of it as a rectangle or a brick. A cuboid is a brick. A sphere is a ball. A cone is what you eat ice cream out of. A cylinder is what you drink beer out of. A pyramid is what the Greeks made. A cube is what you sit on. But a cube is equidistant on all four sides. I mean, all six sides. There's 6 sides to a cube, as we will find out, or as we found out the other day when we built it. Again, there's a couple of tricks here. 3, 4, 5 one I already told you about. One of the other things about another way to find a right triangle is on the 2 sides. If the hypotenuse is twice the size of one of the legs of the triangle, you have a 30, 60, 90 degree triangle. So if the hypotenuse is 2x and one of the sides is x, by definition the other side would be x times the square root of 3, as it happens. But that'll be a 30, 60, 90 degree angle. If you're trying to see if something is square, if you measure across, again in this diagram, if you measure across from A to C and then from B to D, and those are the same distance, you have a square, you have a rectangle. You have something that is square. Cool. All right, we're gonna watch a little video that's gonna show you about creating segments, copying angles, all that sort of stuff, but it's easier than having me talk about it.
In this video, I'm going to be demonstrating construction techniques. Generally speaking, what I'm going to be doing is drawing some pictures. But the word construction is very, very particular. It means that you only get to use 2 instruments. You get to use a compass and you get to use a straight edge. Now, when you look at my straight edge, you're going to notice that it has numbers on it because it's actually a ruler here. And even the compass that I'm showing here has numbers on it. But none of those numbers are going to be used in drawing any of these pictures. A compass is a tool that is used to make arcs and circles. A straight edge is a tool that's used to draw straight lines. We will not be allowed to use measuring devices such as rulers and protractors. Okay, now the tool that I'm actually going to be using when I do all these techniques is sort of a combination of these two, which is this thing here. Okay, the compass has a pointy part, then it has a pencil here. The point is going to be the center of any circle or arc that you want to make. Okay, so if I were interested in making a circle around this, I would just put the point here, the pencil, I'd match it up with that point, and then just pivot around that pointed part to make a circle. It can be used, it takes a little bit of practice, but it is a bit of a complicated one. The tool that I'm going to be using is this. It's technically referred to as a compass, okay, but it has a straight edge built into it as well. Okay, instead of using the pointy part to center it, what I do is use this little eyelet. Just make sure that the center is right through there, okay? Just hold it down there, and then I can move this piece out, sort of like opening up the other compass. I can move this part out to whatever I need. Suppose I want to measure out to there. And it's a little bit tricky to get them in the right spot, but once you do, you've got it. And then your pen or pencil, you just put into that little hole so that you can make an arc. Okay, so for our first construction technique, what we're going to do is duplicate a segment. We're going to draw it in a different location, but it's going to be the same length as the segment that's shown there. Okay, and to start that off, I'm going to begin with just a straight line somewhere that would be longer than this. Okay, I'm going to give it one well-defined endpoint, which will be here. Let's go ahead and call that point A, let that be A prime. Okay, so what I'm looking for is another point. Let's call that point B. That would mean that I'm looking for B prime, and B prime is going to be along that line, the right distance out, that would be comparable to A and B. Okay, so now going back to my compass, I had already measured a length from A to B when I moved this piece out. Okay, so it's already set there, there's no reason to change it. I'm going to take my compass and center it at A prime here, and then just make an arc that goes through the line that I drew. And the point of contact is going to be B prime. Okay, and then you've got some extra things you can choose to erase if you want. You could get rid of the extra stuff they have here. I'm going to leave a little bit just for the sake of the picture. And you can also remove a little bit of the arc that we have there. Okay, so if all you really wanted was A prime to B prime, you can just take that out, take that out and take that out, but I'm going to leave them for the sake of just keeping them in there. Okay, so the idea behind why this works is that every point that would be along this arc is going to be equidistant from A. Okay, because we're really just drawing part of a circle. And the distance out is just the radius. So any point that is on that arc is equidistant from point A. Okay, so when I go over here and I draw that arc, every point that would be along that arc is the same distance away from A prime. But the one point in particular that I want is the point of contact here, which is at B prime. For example 2, we're going to be duplicating angles. And as we go through the examples, I hope you notice that they get a little bit more interesting from one to the next. A little bit more clever in how we approach these things. Okay, so to duplicate an angle, what I'm going to start with is a picture of just one of the rays. All right, and the direction that I draw it doesn't really matter. I just wanted to draw a ray. So let that ray represent this one if you want. Okay, let's go ahead and call this C. Let's call that C prime, just so we have some reference. The first step is going to look like this. I'm going to take the compass and center it at C. Then I'm going to move this part in until I have a measurement that does not go beyond the ends of the arrows. You don't want it to be super close to the center, but you can't go past the edges there. That should be pretty good. And I'm going to make an arc that goes all the way across. So I get 2 points of contact. I get a point here, get a point here, which happen to be the same distance away from C because they sit on the same arc. Okay, now what I'm going to do, without changing the setting here, I want to keep this the same. I'm going to go over to C prime and make an arc that looks like that too. Probably a little bit longer than the one that we see, just in case. Okay, so I got that arc. And at this point, I'm going to change the setting of my compass. I'm going to center the compass at this point, rotate in the direction of the other intersection, and I'm going to measure out to that one. I'm going to figure out basically the distance between that point and that point. Here. Okay, so somewhere along this arc, there's going to be a point where the other ray needs to go through. And that point is going to be this distance out. So I'll take the compass, center it here, rotate around, and I hope I do the first one long enough here. Cut it about as close as you possibly could there. So right at the end, usually that arc will go, you should draw it a little bit further out. So it looks like that. Okay, but the distance from here to there is the same distance that would be from here to there. So if I connect like that, then this angle is a copy of that angle. And if you want to, you can add one more little arc just for the sake of helping you remember. Be a little one right there. Okay, so you can see that that one matches what's happening here. All right, to demonstrate that this did work, or at least got pretty darn close to it, using a compass is not always going to be perfect. What I'm going to do is take a protractor and take some measurements. Okay, so for here, for the original angle, it appears, so it doesn't reach all the way across, but it looks like it's right between the 70 and the 80, which would actually be 105 degrees. Okay, and then over here, it looks like we get the same thing, right between 70 and 80, which should be at 105 degrees. Example 3, we are going to create a perpendicular bisector. What's really neat about this one is that the way that we're going to construct it is going to be based off of a theorem that we have for perpendicular bisectors, which had said that any point that is on a perpendicular bisector will be equidistant from the endpoints of the segment that it bisects. Okay, so what we're going to do is identify 2 points that are equidistant from the endpoints that we have here. When we connect those 2 points, we will get a perpendicular bisector. So to do that, we're going to take our compass, we're going to center at one endpoint, and what we're going to do is we're going to measure out so that we get at least a little bit past halfway. Okay, you don't want to measure really far, but make sure that you're more than what you think is halfway across. Okay, and then from there, what you're going to do is make an arc up there, and you can actually choose to draw all the way through this direction. I don't like to do that, so I just go ahead and start up again over here, but you could make an arc that goes all the way around. Okay, and then keeping that setting. Okay, don't change the setting. You go to the other endpoint, and you make a couple of arcs that intersect those two. And again, you could go all the way across if you want. That'd be fine. I just think it looks a little bit messy, so I break it apart around that segment. But these 2 points, here and here, are going to be equidistant from the endpoints because I didn't change the setting on the compass, which means that if I connect them, then this is a perpendicular bisector to the original segment. You get the right angle and you get the bisecting. That would be there. And then if you got a little bit too much in this area here, you can just take some of that stuff out. And there you are, perpendicular bisector. For example 4, we're going to create an angle bisector. Okay, and this, like the perpendicular bisector, is going to be based off of a theorem that we know, which is that any point along the angle bisector is equidistant from the 2 sides of the angle. Okay, the one thing that's going to be different here versus how it was presented earlier is that I'm not going to rely on perpendiculars. Okay, here's how it starts. We're going to take our compass and center it at the vertex, and we're going to measure out so that we can intersect, when we draw an arc, we can intersect both of the sides here, okay? You don't want it too close to the center, but you don't need it to be really far out. All right, so these 2 points of contact, here and here, are going to be equidistant from the vertex. Okay, so in a way, they're kind of like the same point, but on the 2 different sides. All right, from those points, we're going to find one more point, which is equidistant from those 2. See, the vertex is already equidistant from it. We're going to look for one other point that would be equidistant from these 2 points, which I'm going to place out here. Okay, so I'm going to take my compass, and at this time, you can change the setting if you want to. Doesn't make a difference. But what you want to be able to do is make an arc that's out there in the middle, somewhere where you think the angle bisector is going to go through. Okay? All right, so there's an arc. And keeping the same setting, go over to here and make another arc. And that point of contact is going to be equidistant from these 2 points. So the angle bisector is this. All right, for example number 5, we're going to create a perpendicular. We're going to create a right angle to a line through a point that is on the line. Okay, to do this, we're basically going to steal the idea from the perpendicular bisector. Okay, so the problem that we run into at the beginning, though, is that we don't have any endpoints that are here. We have a point that we want to go through perpendicular, but we don't have any endpoints to work with. Okay, so what I'm going to do is create a couple of endpoints that are equidistant from that given point. Okay, so with the compass, I'm going to center there and measure out just some distance out, not too far. So I can probably just leave the setting as it is, and mark here and here. So these 2 points are equidistant from that one, the one that I want to go through. In other words, this point is a midpoint to these 2. Okay, so now what I'm going to do is center the compass at these 2 points I've created, but I'm going to change the setting here, because if I don't, I'm just going to go right through the midpoint. So I'm going to extend it out a little bit further, about here, and I'm going to make an arc out there, go down to the bottom, go ahead and make an arc. Again, you could go all the way through, but it'll look a little bit messy, I think. Keep that setting. It's important you don't change it here. Make an arc up top. make one at the bottom. And these 2 points are equidistant from these 2 points, which means that when I connect them, I get a perpendicular bisector to those 2 points. And this happens to be the midpoint of them, so if everything went right, when these are matched up, that's going to sit right on the middle. All right, so there's my perpendicular at a point. All right, and for example 6, for whatever reason, this one is my favorite one. We're going to create a perpendicular to a line that goes through a point that is not on the line. That's here. So what I want to do is create a perpendicular that goes from here to that line. I want that right angle there. Okay, and again, I need to steal the idea from the perpendicular bisectors one. What I'm going to do is identify 2 points that are equidistant from that one, but sit on top of this line. And to do that, I'll place the compass at that point, go ahead and measure out just a little bit past that line, okay? All right, so I got it centered here, measure a little bit past, and I'm going to make a big arc that goes through like that. Okay, so these 2 points of contact are going to be equidistant from that. In a way, what I've done is I've created a segment. I've created a segment, and the endpoints are equidistant from that. So if I can find one more point that's equidistant from these 2, I can connect with that and get my perpendicular. So let's center the compass here. Go ahead and make an arc underneath. Here as well. And then I can connect like this. And there's my right angle.
All right, now you know more than you ever want to know about any of that stuff. All right, a couple more things, we're out of here. We're getting so close to the end of our geometry lesson. Aren't we excited? An ellipse is a flat surface, just it has 2 focal points. And the way you draw it is to, for instance, hammer a nail into 2 focal points, take a string and tie it around a pencil or pen. And then as you go around the ellipse, it will create an oval shape. But that's what I mean by 2 focal points. You have to have those 2 focal points there. Now, in lighting, an ellipse is very important because it allows us to put shutters and things on our lighting instruments. But if you're creating an oval, an ellipse is a great way of creating that the thing flat there for you. If you're dividing a line into an equal distant thing, you take the line and you take a ruler, the easiest way to do it, and just put the ruler at A, and then mark 1 inch, 2 inch, 3 inch, 4 inch as you go down the ruler in some angle, doesn't matter what. And then connect the last 2 dots, and then draw 2 parallel lines, or however many parallel lines to that, and you will automatically divide the first line into equidistant distances. Yes? A parallel line, if you have one line that you've drawn, and you draw another line just across the line to create the 4 angles there. If you copy the angle on C, we talked about copying an angle just a little second ago. If you copy angle C to make it set angle A, then copy Q and D, you can create 2 parallel lines. Again, that's using the same trick that you just used with compass. Finding the center of a circle is great to use a carpenter square. You use a carpenter square and then connect the points across the circle. The middle of the ruler is if you do that twice, where the 2 lines cross will be the center of the circle. Another great way to do that is to have the circle, especially if it's a larger circle, stand it up on edge, and then take the carpenter square and draw a straight line up, and then turn it and draw a straight line up, and where those 2 lines cross, that's the center of the circle. Yes, if you have to find it that way. And oftentimes we have to do that, especially in going around, that sort of thing. Cool. All right, we're going to talk a little bit about drawing faces and that sort of thing, and then that'll be the end of the day. Good morning, sunshines. Today, we're going to learn to draw. Yay! I'm going to separate this into 3 little sequences. First, today, we're going to learn to draw a face. Then the second episode will be drawing the figure. and the third episode will be drawing in perspective. So today, right now, we're going to start drawing a face. So hopefully you have a pencil and a piece of paper, or a pen, doesn't matter, and something to draw on, a piece of paper of some sort. So what I want you to do, everybody, I can assume that you can hold a pencil in your hand. If you can't hold a pencil in your hand, it's going to be tough to draw. But I assume that you can hold a pencil in your hand. The first thing I want you to do, don't think about anything, just on your piece of paper, draw 5 circles. Just very quickly, 1, 2, 3, 4, 5. 5 circles, fast and quick. Now, look at your circles. One of the things about drawing is that you should edit as you go. So I want you to look at your circles and pick the worst one. Pick the worst circle you made. I think that one, I think, is my best circle. I think this one is the worst circle. That one's not too good, but I'm gonna pick this one as my worst circle. Yes? Now, pick your worst circle. The important thing about picking your worst circle is it's already screwed up. You have already messed that up. So there's no tension about screwing it up any further. If I messed that one up, I've messed up my perfect circle. So I'm gonna save my perfect circle for last. Yes? But I'm gonna learn on my worst circle and then work up to the best circle. Yes? Now, first of all, the first lesson is not all faces are circular. Matter of fact, that probably works best for a face. It doesn't work well for a circle. But what we're going to talk about is the proportions of a typical face. Obviously, people have different sizes, noses, eyes, ears, all that sort of stuff. We're just going to go with the typical measurements of a typical face. Yes. Once you learn to draw, you can get over the phobia and the fear of it. Then you can start worrying about making drawings that are particular drawings of particular people. Right now, we're just going to draw a non-particular face. First thing I want you to do is divide the circle approximately in half. Give yourself a little dotted line, approximately halfway through. Don't take a ruler, but just approximately halfway through. And then also give yourself a little dotted line approximately halfway. Now, as you can see, because my circle sort of has a lean to it, a cant to it, the middle of it sort of has a cant that'll lean to it as well. Yes? Now, let's talk about symbols. When you were taught to draw, my guess is, or excuse me, when you were taught to write, my guess is whoever taught you in kindergarten to make an A, taught you to make an A something like this. Now, probably none of you make an A like that. Probably you moved on to some other form of A. There's the Alabama A, there's the Atlanta Braves A. We've got all kind of A's. People make A's like that. Some people still do it the old-fashioned way. I make my A's like that. It's pretty close. But anyway, there's the way it was intended to be drawn, and there's your style that you add to it. Yes? So what I'm going to do is give you a symbol for an eye. Your eye. What you want to do is draw a little dot, and then have a little parenthesis that touches the top of the dot. A little dot, a little parenthesis that touches the top of the dot. Again, the problem is if you have the dot and your parenthesis doesn't touch the dot, it's going to look like you're scared or mean or something. But just for your casual eye, you want the dot to have a parenthesis, and that's all it is, a little parenthesis, that touches the eye. Yes? So, what I want you to do is divide your halves into half, and where those cross, that's the dot of the eye. Most people's eyes are at quarter line halfway. Now, of course, the dot and then the parenthesis, yes? Now, about halfway down between here and where you are, draw yourself another dotted line, yes? I don't know if you've ever seen the movie Pocahontas. Again, just another symbol. Pocahontas' nose is that. I promise you, that is Pocahontas' nose. If it's good enough for Pocahontas, it's good enough for us. So, take your little Pocahontas nose and put it right there. Again, eventually people have larger noses, smaller noses, although it would be tough to have a smaller nose than Pocahontas. But you have your little nose right there. There's your eyes and your nose. Cool? We're halfway through. Draw yourself another line approximately halfway between the nose line and your chin. Yes? Now, here's where you sort of need to decide whether you're drawing a man or a woman. And I'll show you the reason why. First of all, lips, we're going to draw a half line from a little humpty hump from the midline to the eye line. That's normally people's lips part about where their eye is in. Again, some people's eyes are narrower, some people, but for the most part, that's where our lips are. Now, I'm going to tell you, for whatever reason, if you put the bottom lip in, to me, it just makes that figure look feminine. Yes? So if this is a male, just leave that bottom lip off. If this is a female, put the bottom lip in. Again, I'm going to show you a drawing of somebody else does it. What he does is he just draws part of the bottom lip in for a male. Yes? Now, if you want to put facial hair in, if you're drawing a man, don't like drawing lips, you want to draw some mustaches and some beards and some goatees and whatever else, that's fine. Here's a little sketch with Freud with his little beard. Again, your hairline, about halfway up between your eyes and the top of your head is where your hairline is. I know some of us have a hairline that's a little bit higher than others, but for the most part, your hairline is there. Now, if you have bangs, obviously the hairline comes down below your bangs. If you don't have bangs, your hairline goes above it. Now, ears typically are from your eyes to your nose. Again, some people have, like Barack Obama, have ears that go from, are like Dumbo elephant ears. But ears are just, again, a little comma outside the line of your head, between your eye and your ear. Again, fill in the gap with your hair. You can go ahead and decide to give them, some long curly hair, whatever you want to do. Give them a little mullet. You're typically your neck is just to the outside of your eyes. There are people who work out a lot. You've seen them whose necks are like way out here. Yes, so you could be way out here with your neck, right? For an athlete, something maybe like that. If you're a woman and you have a slender neck, it may come in a little bit beyond that. Yes. But there is the basic proportions of a face. You want to divide the drawing in half, divide the drawing in half, divide it in half. Where the quarter line crosses the half line is where your eyes go. Your symbols for your eyes are a dot with a little parenthesis on the top. Symbol for your nose is a little upside down parenthesis. Your lips, parenthesis, and again, if it's a male, don't worry about the bottom lip. You can add ears, you can add hair, whatever it is to make the figure complete. You've got 4 more circles. Watch this little video that I'm going to include that shows you how this man sketches, because again, it's very similar. Eventually, you want to get to the point where you're not having to, you can imagine where the lines are, you can imagine where the quarter lines are. So eventually, you just want to get to the point where you just have the dots, but you don't necessarily have the actual hash marks. So eventually you work your way to the point where you can do the drawing without having to do the separate pieces, and then you can create the face the way you want it. Again, people like Stewie, have a football head. The proportions are still the same though. Stewie's eyes are still quarter line out, his mouth, his lips, all those sort of things are that way, right? So the proportion, no matter what the circle may look like, the proportions are still the same, right? Let's see, what's the guy's name? Is the guy's name Stewie in Rugrats? Yeah, I think his name is Stewie, the little baby.
That's Tommy.
Tommy. There's my little picture of Tommy there. But Stewie is the football guy, yes? So watch the video, come back for the video, and draw your figure in your other 3 drawings. Again, practice makes perfect. The more you do it, the more you connect your synaptic connections, the easier this gets, the quicker you can draw your little face. And again, trust me, the face is the hardest thing to draw, because that's what we look at most often is the human face. And so when we mess up the face, we recognize it more quickly than if we mess up any other thing. Okay? Enjoy the video and enjoy the sketching the rest of your circles. You made it. You survived geometry. Yay! See you next time.